I wanted to make this video today because my students are having to find the area of various types of polygons, and I wanted them to have a video that they could refer to in case they need help with their homework tonight. Now here we have perhaps one of the easiest polygons that most kids, they know how to find the area of a rectangle. Most kids, by the time they're in 6th grade, they've done this so many times, they know the formula very well. And the formula for finding the area of a rectangle is area equals length times width or base times height. Now I'm going to say base times height because most of the shapes that they're going to have to find the area for, it's going to have some form of height or base that they have to refer to. So I figure we'll start out with this easy one and we'll use area equals base times height on it. Now here, all I'm going to do is say, plug in the values for B and H for base and height. I'm going to say 5 1/4 inches times 11 inches. And then that'll give me what the area is. So I'm going to have 5 1/2 or 5.25 times 11. Now, but I'm just going to go ahead and work it out using the standard algorithm. And I'm going to change the color to blue. So, well, let's change it to red. All right, let's say that I take this 5 1/2 and I make it an improper fraction. 4 times 5 is 20. 20 plus 1 is 21 over 4. And to make this whole number 11 an improper fraction, I just have to say 11 over 1. Now I say 21 times 11 and 4 times 1. Well, 4 times 1 is 4. If I have 21 times 10, I'm going to break this one apart. 21 times 10 will give me 210, and then another 21 would give me 231. So 231, and now I need to convert this improper fraction to a mixed number. So I just have to divide my numerator by my denominator. So I'll come over here and say 231 divided by 4. 4, I can get 5 groups of 4 out of 23. And I can get 7 groups of 4 out of 31. And that'll leave me with 3. Now this 34 means I got this 57 tells me I got 57 groups of 4. So I have 57 whole groups of 4, and I have 3/4 left over. And my unit measure is inches squared. So my final answer on this one would be 57 3/4 inches squared is the area of this rectangle. Now I want to point something out. I want to point something out with this one. When you look at a rectangle, I could actually break it into something, and I have students who are in the room right now. I'm going to go ahead and let them help me here. When I split that shape in half, when I split it in half, boys and girls, what shape did we make? All right, what shape did we make? Okay, Bryce?
You made a triangle.
I made a triangle. I made a triangle. So, would it make sense to you all? Would it not make sense then, if I had to find the area of a triangle, I could use the same formula for finding the area of a rectangle. I could use the same area formula for a rectangle, but multiply it by half. If I multiply it by half, that should give me the area of a triangle. And sure enough, when I turn to the next problem, I have
Caitlin Gibson, come to the office, going home.
I have a triangle. So let's go ahead and look at the formula for finding the area of a triangle. I would say in my formula, area equals 1/2 base times height. And if I want to do the area of this particular triangle right here, I would say area equals 1/2 and in parentheses. Now, because of the commutative property, the distributive property of multiplication, you wouldn't have to do it like this. You could simply divide the base by half and then multiply that product by the height. But I always did it this way, and this is the way I'm going to show my students. Now, the base, when I look at this one, is going to be this line right here. And notice that we are at -7 and we're at +8. Now, boys and girls, when you have a line segment that goes from one quadrant to another quadrant on a coordinate plane, how do you find the length of that line segment without going through and counting those individual units? Carissa?
You would add -7 with 8.
If I add a -7 and 8, I'd have +1. I have to add absolute value of -7 and absolute value of 8 to get the distance. And so that would be 7 plus 8 equals 15 units. So I can say that the base is 15 units here times, and the height is this line is represented here. Now this red line segment, I put this in earlier, it's not part of the triangle. It's kind of like, think of it like the equator. The equator is an imaginary line that goes around the earth. Well, here, this line segment here I put in, it's just to help me figure out the height. And I will go ahead and, if I have a point here at 1 and a point here at 6, because we're not going from one quadrant to another, I can subtract absolute values, and 6 take away 1 will give me 5. Now, I can just go ahead and multiply everything out. In parentheses, 15 times 5 is going to give me 75. And half of 75, well, half of 70 is 35. Half of 5 is 2.5. So half of 75 is going to be 37.5. Now, my unit measure in this case is just going to be simply units squared. Units squared. Now let's look at the next shape. Okay, here I have another triangle. I'm just going to go ahead and skip it. Another triangle. Okay, here we have a parallelogram, and because these symbols tell us all four sides are congruent, it's a rhombus. Now, what I would say here is, what I would do here is just say, well, let's look at it this way. I have a triangle right here. Boys and girls, do you see that triangle right here? When I look at this triangle here, I know that the formula for a triangle is area equals 1/2 times base times height, right? Right? Okay, here's the thing. If I have a triangle here, and because all the sides are congruent, this is another triangle. There are two triangles of equal area. If I find the area of this triangle, what do I have to do to find the area of the whole rhombus? What do I have to do, Mackenzie? Times it by 2. Okay, she just said times it by 2. Well, let's talk about this for just a second. If I use this formula to find the area of this triangle here, and then I multiply it by 2, I've done some steps I didn't need to do. How about I don't divide BH, base times height, I don't divide them by 2. I don't times them by half, and I just use the formula area equals base times height. Will that work? Yes, it will. It will work. So area equals 15 for the base times 4.97 for the height. Now, I'm not going to continue working this out, because I just want to demonstrate the formulas that you can use to solve these. But you could work that out, and then your area unit of measure would be, I'm going to put, well, I'll tell you what, instead of a question mark, let's put a variable to represent the unknown. I'm just going to put x centimeters squared. Okay, let's go ahead and look at another shape. Here we have a trapezoid. This is an isosceles trapezoid. I can tell that because if you go from here to here and here to here, those sides are congruent. Now, there is a formula for finding the area of a trapezoid, but I could, if I wanted to, I could break this shape into triangles. Like I've got a triangle here, I've got a triangle here, and then I've got a rectangle here. I could use the formula that way and do it. I could say area equals 1/2 times base times height for one of the triangles, and then that same formula I could use for the other one. I mean, if I really wanted to do that, I could. And then I could say area, I apologize for getting messy, area equals base times height for the rectangle. I could do that. But that would take a lot of time, and there's a formula for trapezoids that I would use. And that's what I'm going to recommend to my students. The formula that I'm going to recommend is this standard formula for finding the area of a trapezoid. And that's going to be 1/2 the height times base 1 plus base 2, and that will give you the answer. Now, let's go ahead and work this out. I know that the height of this particular trapezoid is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 units high, and half of 9 would be 4.5. Base 1, and always consider the bottom base, the base 1, is 1, 2, 3, 4, 5 units across, and base 2 is 3 units across. So I could say area equals 4.5 times 8. And then area equals, well, if I have 4 groups of 8, that's 32. And if I have 8 halves, that's going to be 4. So that's going to give me 36 units squared. Okay, now let's look at another shape. Okay, here we have a parallelogram, and we can use the same formula for it that we talked about a moment ago with the rhombus that we had, base times height. The base would be 8.5 feet, or 8.5 feet, and the height is 2.5 feet. This value here for this side length is what we call extraneous data. We can ignore that and just focus on the base and the height. So I'll just put X over that. Okay, here, this is an example of what we call a right trapezoid, and it has the same formula. But now this right trapezoid is actually kind of, to me it looks upside down, but it doesn't matter. The formula is the same. Area equals 1/2 the height times base 1 plus base 2. And in this case, I would say base 1, 7.9 meters, 11 meters, and the height, 3.5 meters. If you plug in those values, it's a very easy problem to figure out. Here we have a composite shape, and we'll get more into composite shapes later. I just want to make sure that my students have a good understanding of basic formulas that they'll encounter. So at this point, I'll stop my video. Now, if students were to ask for a math practice, how I solved my answers, I would say I used what I know. This is Thinking Like a Mathematician number 3. I used what I know about finding the area of a polygon. And then you can pick whatever specific polygon you're dealing with. Now, I hope that this video helps my students with their homework tonight, and it'll be on YouTube so they can view it, stop and pause as much as they need to.